There's a gray powder coming out of Chinese labs and factory lines right now, and every ingredient in it is garbage. Steel slag, red mud, phosphogypsum, carbide slag. The stuff mills and refineries pay to get rid of. Grind it, blend it, add water, and it hardens into a binder that is tested stronger than ordinary Portland cement at a fraction of the price, without a single kiln ever being lit. The strength numbers are real. The cost numbers are real. And they're already written into a Chinese national standard. But here's what almost nobody covering this story has noticed. This was never really about cheaper cement. There's a number buried in the chemistry of every sidewalk, every bridge, every building on Earth, a number no amount of clean energy can fix, and this powder is China's answer to it. By the end of this video, you'll know exactly what that number is and why it decides who builds the future. But first, you need to understand why cement never changed. For 200 years, cement has been made one way. You dig up limestone, you grind it with clay, and then you burn it at around 1,450 degrees Celsius, hotter than most lava on Earth, until it fuses into something called clinker. Grind the clinker again, and you have Portland cement. 2 grindings and 1 burning. That recipe consumes about 3.3 gigajoules of energy for every single ton, and the industry has thrown a century of engineering at it without ever escaping the fire. The fire seemed non-negotiable. It's the fire that transforms dead rock into reactive minerals. But here's what Chinese materials scientists understood. Industrial waste has already been through the fire. Blast furnace slag came out of a furnace hotter than a cement kiln. Carbide slag, phosphogypsum, steel slag, the energy bill for cooking those minerals was already paid by someone else for a completely different reason. The minerals are sitting there pre-cooked. They just needed a chemical key to wake them up. And China found the key. A team took wet ground blast furnace slag, mixed it with phosphogypsum and carbide slag, 3 waste streams, 0 clinker, and produced a binder that reached 45.6 megapascals of compressive strength. That number didn't just approach ordinary cement. It exceeded it. To picture 45.6 megapascals, every patch of that material, the size of a postage stamp, can carry the weight of a grand piano. No kiln, no coal, no quarry. Garbage in, load-bearing strength out. But one strong block in one lab doesn't change an industry. What makes this story different is that it isn't one lab, and the ingredients that perform best are the ones that have no business working at all. Because the price, the number everyone fixates on, is honestly the least interesting number in this story. The most important one has been hiding inside the kiln itself. We're getting there. Here's the strange part. Individually, most of these wastes are useless as glue. Researchers in Tianjin documented that fly ash and red mud, on their own, fail to solidify at all. Red mud is worse than useless. It's a caustic sludge from aluminum production, so alkaline, it threatens groundwater, with more than 350 million tons of it stockpiled across China in toxic red lakes. But mix the dead wastes together, and they switch each other on. Red mud's extreme alkalinity, nearly 22% sodium oxide, becomes the activator that dissolves the others. Phosphogypsum sulfates drive the growth of ettringite crystals. Steel slag's calcium feeds the formation of CSH gel, the exact same binding glue that holds Portland concrete together. One material's poison is another material's ignition. And the numbers that came back are genuinely hard to believe. Red mud plus phosphogypsum alone, 40 megapascals, with 0 cement and 0 heating. Steel slag, slag powder, and desulfurization gypsum, 50.57 megapascals at 28 days, comfortably above the 42.5 grade that ordinary Portland cement is literally named for. And one formulation hit 44.45 megapascals in 3 days. Portland cement gets an entire month to reach that number. This did it in 3 days. Which brings us to the part that breaks the economics. In China's mines, solid waste binders are being formulated at 121 yuan per ton. The national average factory price of cement was 466 yuan. That's not half price. That's roughly a quarter. Even the high-performance structural grade, the one that beats cement's strength, costs 68% of what cement does. And it carries just 13% of the carbon. 466 yuan became 121. 100% of the carbon became 13, and the strength went up. But here's what most people miss about that 13. This is the part I've been building to. The single fact that reframes everything you've heard so far. Because the real reason this material exists has nothing to do with your driveway. To understand why Beijing cares, you have to look at two mountains. The first mountain is physical. In 2024, China generated roughly 4.11 billion tons of industrial solid waste. Only 2.37 billion could be put to use. Nearly 900 million tons went straight to disposal, joining a national stockpile of around 6 billion tons, waste that swallows land, leaches into soil and water, and costs companies real money to dump. Steel slag and furnace slag alone pile up at 300 million tons a year, which means the raw material for this new cement is something Chinese industry is currently paying to throw away. The feedstock isn't cheap, it's less than free. The second mountain is invisible, and it's the reveal this whole story has been building toward. Cement's carbon problem was never mainly about the fuel. When limestone becomes clinker, the rock itself releases carbon dioxide. It's the chemical reaction, not the flame. In China, every ton of cement emits about 0.78 tons of carbon dioxide. Globally, cement pumped out 2.6 billion tons in a single year, 5 to 8% of everything humanity emits. And here's the trap. You cannot solar panel your way out of it. Every green grid on Earth could power those kilns, and the carbon dioxide would still pour out, because the stone itself is the smokestack. There is exactly one exit. Stop making clinker. And China, the country that produces more than 60% of the world's cement, has quietly built that exit and written it into law. National Standard GBT 28294 now governs steel slag composite cementitious materials. The binders are going into structural concrete, roads, soil stabilization, and 3D printing. And in 2026, a clinker-free blend was designed to fill the tunnels of the Jingxinda coal mine. So no, this was never about cheaper cement. It's about taking the two great liabilities of the industrial age, the waste mountain and the carbon, and welding them into a single asset. So step back and look at the scale this lands on. Between 2011 and 2013, China poured 6.6 gigatons of concrete, more than the 4.5 gigatons America used in the entire 20th century, the century that built the Hoover Dam, the interstate, and every classic skyline you can name. And the updated numbers are wilder. China now uses that much roughly every 2 years. So whoever changes what cement is, changes it for the majority of everything being built on this planet. The West's leading plans mostly try to capture the carbon after creating it. This material simply never creates it and gets paid in free raw materials for the privilege. Watch what happens next. The standard's spreading through Chinese industry, the first landmark structure poured without clinker, and the day this powder starts crossing borders. The feed is documented, the chemistry is real, and the implications are only beginning. For 200 years, the modern world was built by burning stone. The next one may be built from everything the last one threw away.